Okay, so I hope everybody had a good 3-day weekend. Didn't have to get out in the snow too much. We got the snow we were wanting. It just came one day too late. So, fortunately, that's the way it goes sometimes. But that's good. I'm sure we'll get another snow by the end of the winter season. But go ahead and kind of give you an overview of what's going to be happening. We're going to continue the notes that we were working on last Thursday. That would be inverses of the trig functions, which there should be some extra copies over there in the filing cabinet if anybody has lost or misplaced one or just needs one in general. But we're going to continue with that. I'm thinking today and tomorrow we'll get as far through the notes as we can. On Thursday, we'll go ahead and do some of the questions on the assignment together, and then we'll just go ahead and have that due on Monday. I think that's going to be the plan. You won't be doing all of them, and I'll let you know which ones I'll have you omit. But on Thursday, one other aspect I want to do is one at a time, call you up to the computer. I'm going to give you a number, and I'm going to tell you what to do with it. I'm going to help you calculate your semester average. So I think most people are sitting pretty good in here. The final is not going to be too important to you. Some people, you are going to be dependent on the final in order to get a passing grade for the semester. But I'm going to help you figure out what your semester grade is and then, how important the final is. Have I talked about the final yet? Okay, the final itself, I've got a review of 21 questions. They're all multiple choice, and the final will be 10 of those exact questions. So I'm not changing anything about them. Now, the order, yes, but the problem itself, the multiple choice answers, all of that's going to be the same. So technically, you're going to have seen the final before you take it. You just won't know exactly which 10 out of the 21 are going to be the final itself. So if you look at the review, you should be set to go for that final. Yes, ma'am. Yes, it doesn't include the answers. Now you got to work. We'll work through them together. I won't give you the answers, but you guys will work and help tell me what the answers are. So don't want to make it too easy. But you can use notes, yes. Okay, just like always. So if you basically have the review done, you should be able to come in here and just go tick, 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 and we're done. Okay, and that will be next Friday because next Thursday I won't see you. That's the first day of finals. The rest of the week, this Friday I'm not going to be here, so I'm going to leave, one of two things. You'll already have the homework assignment to go ahead and look at, but you'll also have the review. I'm going to leave that with the substitute, whoever he or she may be. So whether it's the assignment or the review, you'll have something to do on Friday. I'm going to be in the library all day taking care of some business. On Monday, we'll talk about the homework. We'll get it turned in and graded, and then we'll go ahead and start our district assessment. If we don't finish, we'll finish that on Tuesday, so I'm not too worried about it. You guys know at this point it's not for a grade. We just need to get it done. I still want you to try your best, but don't worry, don't sweat the district assessment. Now, whatever time we have left on Tuesday and Wednesday, that'll be time we take a look at the review and we start to fill in some of those blanks so that you're ready for your final. And that is going to be our time through next week. Any questions? Okay, well, it sounds like a plan. This here I put up so I wouldn't forget. Focus activities will be due tomorrow, 12/12. Please make sure to have them ready. We only have 4. I was trying to get 5. I just did not have time to get it created and copied. So if you are kind of worried about your grade, these last grades are definitely ones you want to make sure that you're getting taken care of. This is going to be recorded as a quiz grade. All you got to do is turn in all 4. If you're missing any of them, again, right over there in the filing cabinet should be some extra copies. And then we'll have the homework, and I think those are going to be our last grades. We don't have a whole lot left. Okay, so I think that's everything I needed to cover. And let's go to inverses. Okay, so if you want to get out those notes for me. I think we got through a few problems on Thursday, and then, of course, we took our test on Friday, so we didn't have a chance to talk about it. So it's been several days, but each inverse trig function has a specific limitation on what you can put in and what you can get out. We've had this idea that let me go ahead and do this. If you're trying to evaluate a trig function given an angle measure, remember the answer is going to be a ratio. But if you're given the ratio and you want to know the angle measure that's created, you have to take the inverse. So the inverse of the ratio is going to give me the angle measure. And for the trig inverses, they were very specific about what you can use and what you can't use. So for example, the ratios, what you're putting in, have to be between -1 and 1. And this is one of the things we talked about on Thursday. We talked about them graphically, how this would happen. So your answers have to be between -pi/2 and pi/2. So what two quadrants did that restrict sine inverse to? Yeah, 1 and 4. So we were going to be drawing our triangles in either quadrants 1 or quadrants 4. And the examples that we did the other day, like these, how are we able to tell what quadrant they went in, 1 or 4? Yeah, look, see if it's positive or negative, because sine really is the y value, right? So if you had a negative ratio, this was going to be in quadrant 4. If it was a positive ratio, well, then you're going to be in quadrant 1. Okay, so why don't we go ahead and do a couple more examples to make sure we're back up to speed, and then we'll just get into cosine. All right, so here is another one. Now, one thing I did want to go ahead and bring up, because I forgot about it. We did talk about the fact that sine inverse is going to be in quadrants 1 and 4, but we took a couple days last week to stop and talk about special right triangles because we need to be able to identify what we have. Remember, we had a 45-45-90 and a 30-60-90. So in a 45-45-90, the side lengths were x. The hypotenuse was always x times the square root of 2. Just leg times the square root of 2. Now in a 30-60-90, it was a little different. Okay, across from 30 was the shortest side. We called him x. How did I get the longer leg using that shorter side? We multiplied it by something. Yeah. You take the shorter leg and you multiply it by the square root of 3. Now, in order to find the hypotenuse, again, you take the shorter leg and you do what with it? You double it. Okay, so these relationships have to be in effect if it's one of these two triangles. And if it's not, well, that's when the protractor is going to come in. I'm going to show you how to work with this. Okay, so let's get back to an example. I created one here to kind of help us out. Now remember, we would like our answers to be in radians. So these degrees that are going to come up off the triangles, I went ahead and gave you the radian measures, just to be on the safe side. But if you weren't sure, you can always multiply a degree by what? How do you convert it? Pi over 180, yes. So 30 degrees is pi over 6, 45 degrees is pi over 4, and then 60 degrees is pi over 3 radians. So if you recognize it as a a special right triangle, I mean, you're good. You don't have to do anything. Okay, so let's try this one. Sine inverse of negative square root of 3 over 2. Sine inverse of a negative square root of 3 over 2. Okay, well, I'm going to go ahead and create a grid here. Oops. Thank you, Rick. This thing will move. Hello, thank you very much. Okay. Oh, Brandon Rivera. He's out in the hallway. Hey, Brandon, says you have a parent waiting. Yes.
Leaving. Dang it.
Okay. All right. So I'll go ahead and take that, sir. Yeah, we'll finish it up later. Okay. So help me out. Sine inverse can only be found in quadrants 1 or 4, right? So what quadrant would this one be in? Why would it be in 4? Why can't I put 1? Because it's negative. The sign helps you figure out which one it is. Right, Jalen? Okay. All right. Take care, sir. Oh, thank you so much.
Thank you.
All right. So I'm going to go ahead and draw my terminal side there. And it doesn't matter where. I'm always going to use him to create a right triangle. Okay, so this reference angle is what I'm looking for here. The only thing we need to know is you always start rotating from standard position, the positive x-axis. So I'm going to have to rotate into quadrant 4 here. And I'll explain what that means in just a second. Well, we have the square root of 3 over 2. What's sine's ratio? It's always y over r. It's the opposite over the hypotenuse, right? Okay, so in this quadrant, everybody okay with first how I got the quadrant? Now I'm going to use these sides to help create the triangle. So the opposite should be the square root of 3. And then the radius, the hypotenuse, should be 2. And then, of course, the square root of 3 would have to be the negative. Okay. Now, I want to use the Pythagorean theorem to help me figure out what this missing side is, because hopefully it's going to be one of those two right triangles, either a 45, 45, 90 or a 30, 60, 90. So what's the Pythagorean theorem? I keep forgetting. I'm old. Yeah, a squared plus b squared equals c squared. So the legs are always a and b, right? So I'm going to say x squared plus the negative square root of 3 squared is equal to 2 squared. Well, what happens when I square a square root? Yeah, it just cancels. So this would be x squared plus 3 is equal to 4, 2 squared. Then I'd want to subtract the 3. So x squared is equal to 4 minus 3 is 1. And now how would I get the side length? Yeah, take the square root, right? Okay. So I know that length right there has got to be 1. So here's my question. Is this one of those special right triangles? Okay, which one? Is it 45, 45 or 30, 60, 90? Now, how do we know it's not 45, 45? Yeah, these two legs would have to be exactly the same length, correct? And they're not, so that one's off the table. The only question now, this angle that I'm looking for, is he 30 or is he 60? What's he directly across from? There you go. See, he's across from the longer leg. 1 and square root of 3, so this one would have to be 30. This one would have to be 60. So the sine inverse of negative square root of 3 over 2, I'm going to say that it's 60, but we're just forgetting one thing. If you're taking the inverse and you're in the fourth quadrant, your answer is going to be negative. Okay. Remember, it's what I said a second ago. You have to rotate clockwise into the fourth quadrant. Now, what if I wanted that in radians? Then it would be negative what? We could, but remember, I've already provided you with those. What is 60 degrees? So it would just be negative pi over 3. See, if it's already a special right triangle, then you have nothing to worry about. Okay. What do you guys think? Okay. Well, let's try another one of those. Okay, let me come back up here. So D is the only one I have left for sine inverse. So it says estimate sine inverse of 1/3. Okay, so let me go ahead and get the rest of this off right here. Okay, so sine inverse is always in either quadrant 1 or quadrant 4. So I'm going to put Q1 or Q4. Quadrant 1 or quadrant 4. Which one's it going to be in? Why 1? Okay. It's positive, so it has to be in quadrant 1. That's the first step. You got to decide what quadrant you're going to be in. So just like before, I'm going to draw my terminal side connected to the x-axis. So this angle right here, that's what I'm looking for. Okay. Now we're going to do the same thing. Sine, we know from the previous problem, was always y over what again? Yeah, the adjacent, okay, the hypotenuse, blah, 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 I can't talk today. The opposite over the radius, the hypotenuse. So I know that this opposite should be 1. This one right here should be 3. Okay. So now, let's do what we did before. First off, is everybody okay with what I've done? Well, how do I find the missing side? Yeah. So x is the horizontal. So x squared plus 1 squared equals 3 squared. So 1 squared is 1, so that's easy. X squared plus 1 equals 3 squared? 9. Then I'll subtract the 1. X squared is equal to 9 minus 1, 8. Now this one I'm not going to worry so much about having you simplify those radicals. I probably should, but let's just go ahead and say that that length is square root of 8. Okay. Now, does anybody know what it would be if I were to simplify the radical? Oh, you're so close. 2 square roots of 2. There you go. Because square root of 8 can be rewritten as square root of 4 times 2. And see, I can take the square root of 4, but I can't take the square root of 2 without getting a decimal. So it would have to be 2 square root of 2. Now, let's take a look. Is it a 45, 45, 90? Okay, yep, so 1 does not equal the square root of 8. Okay, so it's not 45, 45. Is it at least 30, 60? No. I mean, a couple of things. One, remember the hypotenuse should always be exactly double the shorter leg. Well, 3 isn't double 2, or shoot, double 1. And if I multiply 1 times the square root of 3, it's not going to give me the square root of 8. So this is going to happen from time to time. We have a triangle that's not a 45-45 or a 30-60. Okay, so what we're going to do is recreate this triangle. We're actually going to go ahead and measure it out and then figure out what the angle is. Okay, so let's recreate this over here. So this is why you needed a protractor today. So here's the triangle that I'm wanting to recreate. We're in the first quadrant. This one right here, that 1's going to be easy. Now what I like to do, I like to measure them out using centimeters. That way it doesn't take up a whole lot of space on your paper. But if you want to use inches, I mean, you're more than welcome to. I saw a lot of students do that in the other classes. This one was 3, and we found this one to be the square root of 8, right? The one that's going to be interesting is trying to figure out the square root of 8. So let's go ahead and say that all of these represent centimeters. Or if you want inches, you're more than welcome to. Okay. What I like to do is go ahead and convert that. First, let's see exactly what decimal I'm looking at. Oh, it looks like I did not have my calculator up. Apologize about that. So while that's booting up, did anybody go out and play in the snow? I went out and made a snowman with my daughter.
Made a very large snowball.
A very large snowball?
And then rolled it down.
Did it hit anything?
Almost.
Cool.
The kid almost got crushed.
Oh, hey, there you go. So that would have been one of those crazy things. He looks up, snow way! You know, it's a pun, say snow. He likes it. Okay, there you go. All right. Well, aside from crushing a small person with a giant snowball, let's go ahead and plug in the square root of 8 and see what we got. So the square root of 8. Okay. So I really need 2.8 centimeters. Okay. But in order to get a more accurate measurement, let's go ahead and rewrite these in millimeters, because that's another unit of measurement that's on your protractor, right? If it already has a ruler on there. Okay, that's the smallest unit of measurement you can have. In fact, if you go ahead and take a look at my ruler that I have right here, see I have inches on one side, centimeters on the other, and then these little tick marks, each one of those is a millimeter. Well, does anybody happen to know how many millimeters are in 1 centimeter? Oh, not 100.
1,000.
Oh, a little less.
What?
1 centimeter is equal to 10 millimeters. So if you were to actually go ahead and count from like 1 centimeter to the other, you should be able to get 10 of those little tick marks. Okay, well, it's really easy. All I want to do, if I want to take 2.8 centimeters and I want to go ahead and make it millimeters, I'm just going to multiply by 10. You can do that every time. Well, that's just going to move the decimal 1 over, but let's say 28.3. Okay. Let's say 28.3 millimeters. Okay. So I want to make this 28.3 millimeters. Remember, 1 centimeter was how many millimeters? Make this 10 millimeters. We don't have to worry about the hypotenuse because we're going to actually measure that angle and see what we get. Okay, so I'm going to use the ruler over here and let's see how close we get. So horizontally, I need 28.3 millimeters. So I'm going to move my ruler over. Remember, every centimeter is 10 millimeters. So there's 10, 20, 28.3, probably be right about there. Would you guys agree? Okay. Now, at that mark that I made, what I'm going to go ahead and do, and I don't know why I have 2 rulers up here. There we go. I'm going to go ahead and measure up 1 centimeter. Okay, so I'm going to go 1 centimeter up right there. And I don't even need to go ahead and draw, the sides of the triangle. From the origin, I'm going to draw my terminal side right through that point that I created. So is everybody okay how I measured that? The 28.3 by the 10 millimeters? Okay, so let me get this guy out of the way. And now, starting here at the origin, see, I'm going to go ahead and put that line right through that point. Okay, and this is what I want to go ahead and measure. Now, Is there anybody who doesn't know how to use a protractor? And there were some students in the pre-cal IS classes who were not. Now, basically all the protractors are going to work the same way. You'll notice mine has this little crosshairs right here. You want to put that right smack dab on your origin. Now, some of your protractors are going to be a little different. You see how they have the hole in the middle? So they don't have crosshairs. You're just going to put that hole right over your origin. And then the lines that are horizontal, these lines right here, you're going to line those up with the x-axis that you have. And then you'll notice, based on where we drew our line, we're going to see what measurement we have. Okay, so let's do this. See, I'm going to take that crosshairs, and I'm going to put it right there in the middle, right there on the origin. Okay, and what I'm looking for is how far we rotated. Now, because of my protractor, you'll notice I have an inside and an outside arc. I'm going to want to use the inside arc. How far do you think we rotated from the x-axis looking at that? You'd say 20 degrees? Would anybody say 21? Or would you say 20? 20, you'd even go ahead and say 22? Okay. And this is where it's going to be a little bit subjective, because am I going to get it exactly? It's not going to be perfect, but we're going to be able to get really close. So let's say that our angle that we're looking for, what do you want me to put, 20 or 21? 21. So let's say 21 degrees. Now let's see how close we actually got. Okay. I'm going to come on over here. If I go to trig, sine inverse, okay, I'm going to type in the ratio that I was given. Remember, this was what, 1/3? 1 divided by 3. Okay. So mine's in degrees, so it's always going to give you your answer based on what you had. 19.47. So how close did we get? We got really close. Okay. So the only time you're going to need the protractor is if it's not a special right triangle, if it's something you don't immediately recognize. So you see what we're doing is we're actually using the angles of the triangle to find the angle. Okay. So let me give you another one of those. Let me give you another one. Okay. And we'll just do it on this page right here, because this is where I've got all my measuring tools. Let me get rid of this. Okay, so let's say I wanted you to find me the sine inverse of, let's say, 3/5. The sine inverse of 3/5. Okay, and let's make it fun. Let's make it negative. Now, what quadrant would I be in? Would I be in 1 or 4? 4. How do I know? Because it's negative, right? Okay, so let me move this up so that I actually have some room in the 4th. So just like before, I'm going to decide on my quadrant. Then I'm going to go ahead and try to draw a triangle here. So maybe this is going to turn out to be a special right triangle. Maybe I'm going to have to measure it. Okay, so here's my theta. Now remember, if it's in quadrant 4, my answer is going to be what? Has to be negative. No matter what, it's got to be a negative answer. Okay. Well, here's my ratio. We've got a y of -3 and an r of 5. So this would be -3. This would be 5. Now, we could go ahead and use the Pythagorean theorem, but does anybody recognize it as a triple? This is a 3 what 5 triangle. What's that? Not 1. That's okay. Was it? 4. It is 4. But let's say we didn't know that. Okay. Let's say x squared plus -3 squared equals 5 squared. Well, what's -3 squared? 9. So x squared plus 9 is equal to 5 squared? 25. Okay. Well, I'm going to subtract 9. So x squared is equal to 25 minus 9? Ooh, 16. There we go. And now I want x, not x squared. There you go. So Genevieve was absolutely right. It is 4. Okay. Now, everybody okay with how I created the triangle? How I got the quadrant? How I got the missing side? Okay. Is it a 45-45 or a 30-60? Which one do we know for sure it's not? Okay, because 3 does not equal 4. Okay, so 45-45 is gone. The answer can't be -45. Is it a 30-60? No, and for a couple of reasons. Is 5 exactly double 3? No, I mean, it's close, but it's not exact. And if I were to take 3 and just multiply it by the square root of 3, would that give me 4? No. So this is another one of those cases where I'm going to have to measure. But see here, the triangle is going to be easy. I just need to go 4 centimeters to the right and then 3 centimeters down. Okay. So why don't we go ahead and do that? I'm going to create this triangle right here. Okay. So how many centimeters did I have to go to the right? Remember, it was 4. Okay. So I'm going to place, and you don't want to place the edge, right? You notice how there's a little bit of space before it starts counting? Where it starts counting is where you want to place it on your y-axis. So right there. So I want to go 4 to the right. So I'm going to make a mark right there. And now from that mark, how far down am I going to measure? I'm going to go ahead and measure down 3. Okay, so let me rotate this right here. So right there, I'm going to now go down 3. Let's say right there. So from the origin to this spot right here, it should be right about how many centimeters? No, because remember, how long was the hypotenuse? 5. So we've created my 3, 4, 5 right triangle. But I'm going to put a line from the origin straight through that point that I just created. Okay, so let's see here. So starting at the origin, I'll go right through that point. Okay. Now the only thing is, I got to turn this guy upside down. Oop, that's not the right one. There we go. Let's turn him upside down. And I'm still going to do the exact same thing. I'm going to go ahead and place those crosshairs right on my origin. Right on top of it. You see how I'm getting close? Right on top of it. Okay. Now, what do you think I'm going to want to use here? The inside track or the outside track? Yeah. Because I'm wanting to rotate here and just see how far I rotate it. And you'll notice I draw my lines pretty long at the very end because I want to make sure it's going to go past the protractor and there's no question about what my answer is. So let's say it's hitting, right about there. What would you say that is? You'd say about negative 36 degrees? That's what you want me to put? So let's say theta is about a negative 36 degrees. Is everybody okay with that? Okay. Well, let's see here. If I come on back to my calculator, we were taking sine inverse of negative 3/5. Let's see how close we got. Bam! Look at that. Look at that. Doesn't that make you feel just as smart as a calculator? You're getting virtually the same answer. All you're doing is a little bit of measuring. Okay. How we doing? Okay. Good. Document B. We should have time right at the end. Come on, delete that. Come on. There we go. I'll come back to that in a second. Okay. Well, here's what I'm going to go ahead and do. I'm going to kind of speed the process along. Instead of showing you the graphs, I have the graphs here. If anybody wants me to give them time to copy, I will. But I think I'll just go ahead and cut right to the chase and show you how these work. Okay. When you're dealing with cosine inverse, you plug in a ratio, and your answer is going to be an angle measure. Okay. Well, the limitations are a little different. Wherever you're able to plug in the cosine inverse, it's exactly the same as the restriction we have for what's going to go into sine inverse. Your ratio has to be between -1 and 1. If it's not, you're going to get an error message. Okay. Now, your answer is going to be in a different location as well. While sine inverse is restricted to quadrants 1 and 4, cosine inverse, he's going to be restricted to quadrants 1 and 2. So his answers have to be between 0 and pi. Okay. His answers have to be between 0 and pi. So cosine inverse, you're going to be looking at the top. Well, we have quadrants 1 and 2. How am I going to know what quadrant it goes in? If it's positive or if it's negative. If it's positive, it's quadrant 1. If it's negative, it's going to be quadrant 2. Yes. Okay. And we're still going to be looking for those 45, 45, or 30, 60, 90 triangles. So if it's one of those, we got the answer. We don't have to worry about anything. If it's not one of those, well, then that's where we break out the protractor. We go ahead and measure it. Okay, does that make sense? Okay. Well, let's just get to some examples. Let's see what you think. Okay. We'll kind of cut to the chase. All right. Now, we'll come back to A in a second. Let's go ahead and start with B. Cosine inverse of -1/2. Okay. So I'm trying to evaluate cosine inverse. So I know my answer has got to be an angle. All right. Well, what quadrant? Quadrant 1 or 2? Why 2? It's negative. Okay. So let me go ahead and move this guy over just a little bit. So I have quadrant 2. So I've chosen the quadrant. Is everybody okay with that? I'm going to draw my terminal side. Okay. Use that to create a right triangle. Now, sine was y over r. What was cosine? Cosine's x over r. So that means adjacent over hypotenuse. So here's the 1. Here's the 2. Which one has the negative? The 1. The radius, that hypotenuse, is always, always, always positive. Okay. Well, how can I find this y value that I'm looking for? What have we been doing on the other problems? Yeah, Pythagorean theorem. So let's say y squared plus -1 squared equals 2 squared. So what's a -1 squared? So y squared plus 1 equals 2 squared? 4. Then we got to subtract the 1. So y squared equals 3. So what's the length I'm looking for? It's got to be the square root of 3. Okay. All right. Now here's my question. Is this a special right triangle? How do we know? Okay, because you'll notice the shorter leg, okay, it is half of what the hypotenuse. The hypotenuse is doubled the shorter leg. If I take the shorter leg, multiply it by the square root of 3, I get the longer leg. Don't worry about the fact that it's negative. The negative just told me the direction we were going. Okay, so we're still looking at that as side length 1. But here's what's really important. This angle right here, would he be 30 or would he be 60? He would be 60. 30 is always across from the shortest leg. Okay, but now here's one thing. You remember how in sine inverse, when you were in quadrant 4, you always have to make sure that your answer is negative? Well, there's one little trick to cosine inverse. If it's in quadrant 2, remember you always, always start rotating from the positive x-axis. So this time, the reference angle is not the answer, but he's going to help me get that. How can I figure out how far we've rotated so that there's only 60 degrees left? Yeah, just subtract from 180. So what's 180 minus 60? 120. So my answer is 120 degrees. Okay. Now, what if I wanted that in radians? Yeah, times it by pi over 180. Now, remember, if it's a special right triangle, we should be getting the answer exactly, right? Let's see. I'm going to come over here. Okay, now it's not going to let me do that because the calculator has some marks on the screen. But let me go ahead and say B. There we go. So we're dealing with cosine inverse. What was the problem? -1/2 of -1 divided by 5. Oh, I'm sorry. I was thinking about another problem. It's -1 divided by 2. Sorry. -1 divided by 2. And there's the 120 that we just got. Okay. Is everybody kind of starting to see the idea behind the inverses? Anybody confused? Okay. All right, so I'll tell you what, we'll go ahead and stop there for today. You guys have done a great job. Yes, now you can go to the restroom. If you will get your calculators and your protractors back up to the front for me. Yes, ma'am. Oh, no question? Okay. All right. Cool. I also want to go ahead and pass back your papers. Oh, let me stop this.